but we are like the smallest team in there doing the network delivery. So we're the team that ensures that Netflix, when you stream it, get delivers to your screen with no button. So since I'm between you and lunch, I'll try to keep my presentations short. So let's move on. So currently we have 130 million members and we are in 190 countries, more than 190 countries. Actually, we are in all over the world, except for 4 countries. That's easy. So except for Congo, our service is not in China. As you know, a lot of OTTs from US is not in China. Then as we are an American company, we are not allowed to do business with North Korea, Syria, and Crimea. So let me go into how Netflix works. So we are the first company in the world which invented internet TV. So the 3 main items for internet TV is the architecture of internet streaming, the quality of experience that our users get, and the last thing is about cost. So I think there was mention of data plane and control plane as well, and similar, kind of look at it a little bit different from Netflix point of view. So as mentioned, I'm from the Open Connect, so that's the data plane of it, if you can see on the upper part. So that is where the streaming happens. So that's where we store all the data or all the content information. And then the second part of how Netflix works is the control plane. So to us, our control plane is where all the compute happens. We actually use Amazon Web Services for our control plane. So all the compute is done on the cloud. So before streaming, I'm not sure if you guys watch Stranger Things, so the background of the slides are all clips from Stranger Things. It's one of the popular contents for the people born in the era 1970. Other content providers, we started launching our services in 2007. That was only in the US. So in 2009, we were using third-party content distribution network to deliver our services. And as we scale and grow, it was kind of tough to kind of outsource that. So in 2011, we decided to set up the internal CDN, which we name it Open Connect. So the main thing in Open Connect is the Open Connect appliances. So they look like this. We call it the OCA in short. Different content call their caches in different names, so ours is the OCA. It's red in color, so we know when you see something in the data center, in red it's the Netflix OCA. So it's designed for bulk storage. So it is very compact. Like this is a 2 rack units, 2 RU box, and it can store up to 200 over terabytes of contents. So this is an even smaller cache we have. It's called the flash, and it is not big in the memory, but the flash or the access is very fast. So it's used to store very, very popular content, so the access time is very fast. Just a snapshot of what it looks in our data center. So Open Connect, which is the data plane, we connect directly to ISP networks. So the concept is to make the content available closest to the ISP's customers. So today, 95% of our traffic is directly connected to ISP. Instead of going through third-party providers, we want to connect directly to ISP for the best performance. So what we offer is we provide the free Open Connect appliances to ISPs, data centers. So if you're interested and have customers using Netflix services, you can approach us for it. So the other way we connect directly to ISPs is via peering. So in Asia Pacific, okay, this I don't have to explain off. You are very familiar with IX and POPs. So going back, so this building is actually the Equinix Singapore data center, SG3, which was completed a few years ago. So we have our POP in this location. In Asia, we are also in Hong Kong, Tokyo, and Osaka, and Mumbai. So these are all the locations where we connect directly to ISPs in Asia Pacific. So another picture of our OCAs, the red one, and the flash, the gray ones. So this is an example of how we connect. So like the IX side, maybe for example, it's Singapore Equinix, get the traffic from Singapore for the cash bill, and then they can serve the local customers directly from the local location. So going into some example of how we bring to our sites, to our OCs in our data center. So this is a picture of the green dots are OCA's locations that we have. So we have deployed OCAs in a lot of places over the world. And the orange dot are the IX POPs that we have, that we do the peering in IX or the direct private peering. So that's the data plane part. So now we go into the control plane. So when you click play for a movie, it first talks to the control plane. So that control plane will take the information of what movie you want to watch, where are you located, what are you using a phone, tablet, or are you using a smart TV? So the language which you chose to watch the movie, the subtitle, the network condition, and connections. So once from the control plane receive the information, what do you want to watch, then the control plane will calculate where can I get it for you. So like, do I go to the theater, the market, the school to get the information you want? So the playback will generate a playback manifest for the playback. So this is how we steer the request to the correct server. So it will actually return to your device. If you're using a phone or a laptop, it will return to the app and tell you that where you should stream it from. So you return the URL, So another thing is that it will also check for licensing. So probably those of you who actually watch Netflix, a lot of people have asked, how come this series is available in US, but I can't get it in Sri Lanka, right? So the reason is licensing. So a lot of contents we actually license from third party, for example, Disney, Marvel, or things like that, and they might already license it to somebody else in Sri Lanka, and we can't get the license here. So that's the main reason. It's not that we don't want to, it's because of licensing that we can't make third-party content available everywhere. But if it's a Netflix original content, which we produce, it's guaranteed that it's available everywhere at the same time. So to summarize, so number one, the OCA is very important because it keeps, so even if when you are playing the content or playing the movie, the OCA keeps talking to the control plane because it keeps updating the network condition, the health of the streams, and all those status. So then in the control plane in our cloud service, the cache control service, steering service, playback apps all work with each other there. So to get the number two, you get the play request, right? And then once you get the play request, we go to determine what assets are required, which OCA to serve you. So what assets are required, because we break our content streams into, like mobile has smaller bit rates. So we have like streams for mobile, streams for different kind of device. So from all those information, the control plane will calculate the best place to get the content for you. So then once it's been calculated, number last one on top, your device gets the URL and it goes to stream from the OCA. The device actually gets three, so we will actually, the control plane will actually provide 3 URLs, and then that's 2 more is for backup. So in case some congestion for example, in Sri Lanka, you probably have a URL from Singapore OCA, from Mumbai OCA, or from some OCA in Dubai. So like if one goes down, it will switch to the second OCA, and then it will recalculate 3 links, so we always have 3 links for backup. So now we go into content filling of the OCA. So our caches fill while you sleep. So it's actually at night. So it actually doesn't use your bandwidth during the peak hours. So files are copied off peak, and you decide, or the ISP who wants the cache decide when it's off peak. So it doesn't actually use bandwidth during the peak hours. So because based on the data we collect, we have predictable viewing patterns. So we kind of know, like for in Sri Lanka, which is the most popular content. So we will know the cache with the most popular content, which probably is now is about 20%. So we have a huge library. For example, we have hundreds of terabytes of content available, right? But usually people watch the latest content, so we'll only fill the popular content, around 20% it locally in caches of ISP. So by that prediction we have, it actually maximizes the offload. So because our OCA is actually purpose-built for Netflix, we don't resell it to other people. So it's very efficient and it serves only Netflix traffic. So we copy the Netflix show into a region once, and then it replicates from the region to the next region. Of course, we use submarine cables for the field as well to copy, for example, from the US. So, for example, while you're sleeping, the content get copied. This is US, and then it gets copied to Japan. And then while the Earth turns to Japan, will fill Hong Kong and Singapore. Singapore will fill towards the west side of the Earth. And this is a typical network graph of any ISPs, I believe. So we fill below are the field traffic, so we only fill at off-peak hours, so we actually don't utilize the peak hours traffic. For example, if a ISP has that much of traffic, 1 terabyte of Netflix traffic, then if there is no OCA in the ISP network, the ISP will need to provision 1 terabyte of international bandwidth. So with a OCA in the ISP network, they just need to provision enough bandwidth for field traffic. So this is QoE is one of the very important factors we measure because we want our users to have the best experience. So you don't want to watch a movie and it keeps getting buffered. So we have the, we calculate how much we need to buffer based on the input rate from the network, the video buffer, and then we will calculate how much we buffer onto the screen. So the input rate changes because sometimes network suddenly gets congested and then we have to buffer a lot. So all this calculation is made by the control plane. That's why the OCA keeps feeding the network health to the control plane. So there is a 3 important factors: the play delay, quality, and the interruption risk. So play delay is that when you click play, how many seconds or milliseconds you have to wait for the video to start streaming. So if we are able to buffer that faster, you'll have close to 0 millisecond play delay. And then the quality of the stream, when you start playing the content, sometimes, for example, when you started the stream, it's on HD. So you're enjoying HD and then suddenly some congestion with the network happen. Instead of buffering, which is not nice, our algorithm will actually change it to SD. So we change from a higher bitrate to a lower bitrate, so we use adaptive streaming. So it doesn't cut off your movie, but we just move from to a lower quality so you can still continue watching. So interruption risk is when we don't want like something happen as a fiber cut or multiple fiber cut, and it's very hard to restore the traffic. But because we always have like 3 URLs, we'll route it to somewhere else. So that's the end of my presentation. So any questions?